Hello, this is Julia Bell, and welcome to CPSC 2770, Chapter 11 of Oracle. We're picking up on Part 4 of our series. We're going to start with the having clause and restricting aggregated output. The having clause is used to restrict groups returned by a query. If you use the group function to restrict groups, you must use the having clause, because the where clause can't group functions. Example, restricting aggregate output. This is coming to you page 398 and 399. The having clause serves as the where clause for group data, is used to eliminate certain groups from further consideration. We did select of category. Again, this is a single. 2 character, we're doing an average of the retail minus the cost. That gives us profit. We're going to output it in this format, $, 3 positions, a decimal and 2 decimal positions. We're going to call that profit. It's coming from the books table. You're going to group that by category, and these are the results that we received. If we run the same command in SQL, again the same results, the same output, and this works. Whereas before, if we run category by itself without grouping it by category, you got usually an error because it was looking for some way to use the category and found it as a single. For computer books, the profit for the entire category was gauged as an average profit of $18.26. This is another example. You use the having clause to restrict which groups are displayed. This is actually Chapter 11, Figure 1121, page 399. I cut off the extra dash here and it went crazy. And I'm saying having an average retail minus cost, which we know is profit, that's greater than 15. Notice I eliminated the 860, the 12, and here's another 12. And another 12 that we didn't consider. So this is another way of using the having that works quite wonderfully. Another way of looking at restricting aggregate output, the same example I gave a second ago. And here's a side-by-side comparison of those two. The group by category. This one we added one more line and we became more selective by using a having clause. Notice those were missing, and that one's missing, and so is that one. With this new query where we listed the having clause of retail minus cost greater than 15. Restricting aggregate output continued. Some other considerations. When included in the same select statement, the causes are evaluated in the order of where, because where filters before your grouping. Group by, and then having is our last filter, and it's filtered after the grouping occurs. Here's an example. Our select statement, category, notice it ties into the grouping. Average of the retail minus the cost, our output format, we're going to call it profit. It's coming from the books table. Where the publication date is greater than the first day of January of 2005, group by category, having an average retail minus cost, in other words our profit, greater than 15. So again, this is the previous query. By adding another line of where, we limit it further. So that led us to computer and literature. Notice the profit amount on computer changed. So we had some older books that were calculated in this number. Interesting thing to know. Maybe those older books might not be around much longer. Something to consider. This one is another having demo. Select the customer number, the order number. We're doing a sum of the quantity times the paid each. We're going to call that order total. From the orders, that's a table, we're going to join it with order items. We're going to use the order number as our field to join on. Group by customer number and order number. Again, those are up here because those work group functions having some quantity times paid each that's greater than 100. So our order total up here had to be greater than $100. Here's the results that we got. Order 112, 1010. When you ran the same item without the greater than 100, notice some of the guys very, very different. Group by customer number, group by order number, but we didn't put this in. Wait, not at all the same. We limited our output here. We didn't get these tiny orders of $44, $41, $85, and $19. It restricted our output. I want to run those same things from the command line. Here is 1122 using the where, group by, and having clauses. Everything together, the one we just ran, where the publication date is greater than this date. Group it by category because you've got category here. It's not a group function. Having an average retail minus cost greater than 15, and it produced two results. This one is using the having clause to restrict the grouped output. Customer number, order number from orders. We're joining order items using the field called order number, grouping it by customer number and order number, and then having the sum order total is greater than 15. So a lot of them met that criteria. Here's the 24 one we just looked at, filtering correctly with the where and having clauses. So this is run, and then here's the other one. This one left the 1826 and the 1655. Notice those stayed. So this one worked well. Quite different reports. So do keep those in mind. This one, it is quite inefficient and considered poor SQL programming practice. The statement must process all the rows in the books table with the aggregate calculation and then eliminate categories. Something to think about. That is 1125. This is considered not really good form. Took longer. You selected from the books, group by category, having, then you did an and. It does work, but it's considered, again, poor programming practice because it takes more overhead to run back through the same tables again. Same results, more efficient. You notice here we used the where right after the from books. Then we did group by, and then we did having. Remember the previous slide where we gave the order that those are processed in? Where, group by, and having. So that is a much more efficient design. Does the other return the correct results? Yes, it did. But in a large database where overhead is very critical, this is something you'll want to keep in mind. I ran 1125 for you. Again, it did run, but this one is far less efficient. If you would run the one where you actually inserted the other clause right here, far more efficient. Nesting. When group functions are nested, the inner function is resolved first. There is a limit. You can only nest 2 levels deep. The query must include a group by clause. Here's an example of nesting. Again, the inner function resolved first. This is an example of inner. You're doing the sum of quantity times paid each. So actually I would do this first. Then I'm going to come up with an average. You actually multiply these out. And that's going to be the average order total. So again, you do the inner first, come up with that sum of the quantity times paid each. Then I'm going to average that from orders, join it with order items, and I'm going to use the field order number, and I'm going to group that by order number. This is the result, 80.383 to infinity. Chapter 11, 1126, the same command I just talked about, where you've got the nested. Again, it ran the sum first and then the average. Statistical group functions. These are used to perform calculations for data analysis. Your marketing department might use those for sales trends. Your accounting department might use this information for price fluctuations. These are based on normal distribution. Statistical functions include standard deviation and variance. The first one, standard deviation, STD-DEV, calculates the standard deviation for a specified field. That means how close each value in a group of numbers is to the mean or the average of the group. Here's the syntax, or how the command is entered. std.dev, you can specify distinct within parens. You can specify all. Note, if the standard deviation function processes only one record per group, the result is always 0. Here's an example of standard deviation. This was actually on page 403, figure 1127. Category, count. Now remember the asterisk, what that means in count. That means include everything, whether it has a 0 or a null value or not. That's what the asterisk will do for us. To character, we're doing the average of the retail minus the cost. We're going to output it in this format with 2 decimal places. We're going to call this average. To the character, standard deviation of the retail minus the cost. In this format, we want 4 decimal places. We're going to call that standard deviation, std.dev. We're using the books table, and we're grouping that by category. Our output category, for instance, computer. We had a count of 4. Again, it counted them whether they were null or whether it had a response. Come up with an average for the book and a standard deviation. Wow, wait a minute. Why so much difference? It looks again at the high and the low, and it's doing something a little different. When I back up, remember how close each value in a group of members is to the mean or the average. In the whole group, there's apparently quite a range. It comes up with $11.22. Quite a difference. Notice the zeros here. The zeros again means that only one record was processed and there's no range to compare it to. So only one record processed equals a result in standard deviation of 0. Using the standard deviation function, same thing. Our count again, the average, a standard deviation, and again the ones with zeros had only one item. So there's no variance, no deviation from a mean to count on here. Variance determines how widely data is spread in a group. Calculate on minimum and a maximum values of a specified field. How close each value in a group is to the mean or the average of that group. If data clustered close together, the variance would be small. If the data contains extreme values, very high, very low, the variance would be larger. The syntax. The word variance, in parens you can put distinct, you can put all, you can use n to represent a numeric field. The variance function. Here's an example. Select the category, variance of retail minus cost, which we consider to be our profit. We're going to output it in this format with 2 decimals. We're going to label it variance. We're going to look at the minimum, the retail minus cost, call that min. We're going to look at the maximum of retail minus cost and call that max from the books table, and we're going to group that by category. Here are our categories. Computer, that's the range, how far the top is from the bottom. Quite a range. Here's the minimum, here's the maximum. Cooking, same type output. When I run that from the command line, I get very much the same results. Family life has gone just wild with a variance there. That'd be interesting to see why. And this concludes part 4.